AI unveiled, 15 data-driven snapshots in 15 minutes. 15 charts, 15 minutes. The complete picture of where artificial intelligence stands right now across 4 critical dimensions: consumer adoption, enterprise implementation, autonomous agents, and underlying infrastructure. We're not talking about distant predictions or sci-fi fantasies. This is the real data showing how AI has transformed from experimental tech to something reshaping every corner of our world. Consider this. ChatGPT reached 100 million users in just 5 weeks, faster than any technology in history. From explosive consumer growth to the infrastructure battles happening behind the scenes, these numbers tell a story that most people are missing. What does this mean for your career, your business, your future? We'll track how AI adoption exploded among consumers, shifted enterprises into full implementation, unleashed autonomous agents, and stressed global infrastructure to find out the consumer AI revolution. Let's start with the numbers that prove this shift is real. ChatGPT reached 100 million users in just 2 months, smashing every record for technology adoption. But here's what happened next that nobody saw coming. The growth didn't slow down, it accelerated. After launching deep reasoning models, ChatGPT grew from 400 million to 800 million users in just a couple of months. Some AI apps are literally experiencing exponential growth cycles we've never seen before. The demographics tell an incredible story. Remember when smartphones were just for tech nerds? AI tools started the same way, but they've jumped straight to mainstream adoption faster than any technology we've ever tracked. Google's data reveals the real usage explosion. Token processing volume jumped 104% from May to July alone, going from 480 trillion to 980 trillion tokens. This isn't just people trying AI once. This is deep integration into daily workflows. What really matters is how people use these tools. This isn't about trying AI once and forgetting it. Daily active users are growing even faster than total signups. People are integrating AI into their morning routines, their work processes, their creative projects. We're seeing usage patterns that mirror how smartphones became essential a decade ago, except this transformation is happening in months instead of years. Consumer spending reveals the real shift. AI tools have moved from fun experiment budgets to necessary expense categories. People are canceling streaming services to pay for AI subscriptions. They're choosing AI writing tools over traditional software. Geographic data shows surprising adoption leaders too. Cities like Austin, Denver, and Nashville are outpacing San Francisco in per capita AI tool usage. This consumer foundation creates something powerful. When millions of people understand AI capabilities from personal use, enterprise adoption accelerates dramatically. The data backs this up. Paid AI subscriptions among U.S. businesses jumped from 25% to 42% between Q4 2024 and Q1 2025. Employees bring AI expectations to work, and companies respond. But what's actually happening inside these businesses tells a completely different story than most people expect. Enterprise AI's tipping point. The deployment data reveals a striking reality. Enterprise AI adoption has tripled from 11% to 33% in just 1 quarter, according to KPMG research. Most companies aren't stuck in pilot programs anymore. They've moved straight into full-scale implementation across their entire operations. The sectors leading this charge will surprise you. Manufacturing companies are running more AI processes than software startups. Banks have deployed AI systems faster than fintech companies. Healthcare organizations are automating workflows that tech companies are still discussing in boardrooms. Traditional industries embraced AI because they had clear problems to solve and budgets to match their ambitions. Meanwhile, 77% of companies actively building AI solutions already use AI for coding assistance and other core workflows, showing how deeply AI has penetrated business operations. The business case drives these decisions. Companies report significant productivity gains and cost reductions that seemed impossible 2 years ago. Organizations see measurable improvements in customer service efficiency, sales cycle acceleration, and operational accuracy. The documented benefits from enterprise surveys consistently show substantial returns on AI investments across multiple business functions. Integration challenges separate winners from failures. Here's the critical insight. Only 22% of organizations report that their current architectures fully support AI workloads, according to Economist Impact Research. Successful deployments follow predictable patterns. They start with specific use cases, invest heavily in employee training, and integrate AI tools with existing workflows rather than replacing entire systems. Failed experiments typically try to implement too much too quickly without proper change management. Budget allocation tells the real story. AI spending has shifted from experimental IT budgets to core operational expenses. Companies now treat AI tools like essential software, not optional upgrades. Some enterprises run thousands of AI processes simultaneously, from automated data analysis to customer interaction management. But the most dramatic transformation is happening at the individual worker level, where AI capabilities are reshaping what humans can accomplish. AI agents take over knowledge work. AI agents are already performing tasks that required years of human training, and they're getting better every day. Legal research that once took junior associates weeks now happens in hours. Financial analysis that required entire teams gets completed by single professionals working with AI agents. What's remarkable is how fast this transformation is happening. Agent performance improvements follow an exponential curve that defies expectations. Meter's consistent tracking methodology reveals tasks that took agents days to complete now finish in hours. The improvement cycle, which used to double every 7 months, has accelerated to roughly 70 days. This means capabilities that seemed impossible in January become routine by summer. The knowledge work domains where agents excel keep expanding. Coding assistance leads the charge, with 77% of AI companies using agents for development work. Following that hierarchy, agents handle content generation, documentation, knowledge retrieval, and product design across industries far beyond tech. Manufacturing companies use agents for quality analysis. Healthcare organizations deploy them for patient data processing. Banks rely on agents for regulatory compliance reviews. Individual workers accomplish what entire teams used to handle. One marketing professional now produces campaign strategies, content calendars, and performance reports that previously required a 5-person team. A financial analyst processes market data and generates investment recommendations at speeds that seemed impossible just months ago. OpenAI's benchmark data shows agents already match or exceed human performance in roughly half of complex professional tasks. The automation zones reveal interesting patterns. People want agents handling repetitive research, data processing, and initial drafts. They prefer keeping strategic decisions, creative direction, and client relationships under human control. This creates a new professional category, augmented knowledge workers who manage both human teams and AI agents. But this explosive capability growth creates unprecedented demands that threaten to overwhelm the systems powering it all. The infrastructure breaking point. Behind AI's explosive growth lies a hidden crisis threatening to slow everything down. The explosive demand for AI is creating infrastructure bottlenecks that could derail the entire revolution. JP Morgan estimates a 10 gigawatt data center capacity shortfall through the foreseeable future. What does this mean? AI workloads are growing faster than we can build the infrastructure to support them. The numbers reveal the staggering scale of compute demand. Tokens consumed per week surged 4,300% year over year. Picture every AI conversation, every generated image, every automated analysis competing for the same limited computing resources. Despite inference costs dropping, demand is rising even faster, creating a short-term misalignment that's putting massive strain on available infrastructure. The choke points stack up across the entire AI infrastructure system. Compute shortfalls hit first, with companies waiting months for critical hardware. Power grids struggle to supply the electricity these systems consume, creating the most acute bottleneck in the entire stack. Each constraint creates ripple effects throughout the system. Geographic constraints are creating AI infrastructure haves and have-nots. Regions with abundant power, cooling capacity, and strategic locations gain massive competitive advantages. Others fall behind, unable to support the infrastructure demands of modern AI systems. Innovative solutions are emerging to address these constraints. Novel chip architectures promise better efficiency. Distributed computing approaches spread workloads across multiple locations. These innovations are essential for sustaining AI growth, but they take time to develop and deploy. Here's why this matters. Infrastructure development faces timeline challenges that could persist for years. The infrastructure race is becoming the defining factor in which organizations and regions will lead the AI revolution. But underneath all these infrastructure battles lies a hidden economy that most people don't even know exists. The token economy explosion. Google's earnings revealed token processing jumped from $480 trillion in May to $980 trillion in July. That's a 104% increase in just 2 months. These aren't just numbers on a spreadsheet. They represent every AI conversation, every generated report, every automated analysis happening across the globe. Token processing has become the hidden metric driving the AI economy. Different usage patterns reveal fascinating insights about AI applications. Simple queries consume relatively few tokens. Complex reasoning tasks eat through thousands. The most exciting AI use cases consume the most tokens, indicating that sophisticated applications drive the highest computational demands. Agentic coding leads enterprise usage, with 77% of companies building AI using agents for coding assistance. Here's where things get interesting. Token processing costs continue falling rapidly, creating opportunities for AI democratization. Applications that seemed economically impossible become viable, but this creates a paradox that's reshaping the entire industry. As inference costs tumble, usage skyrockets even faster. Anthropic had to throttle developer access to Claude because demand exploded beyond their capacity to serve it. Companies that expected lower costs to improve margins instead face unprecedented usage spikes. Token consumption patterns create entirely new economic models. Companies build business strategies around token efficiency. Some optimize their operations to minimize token usage while maximizing output. Others design products specifically to take advantage of decreasing token costs. Token optimization has emerged as a critical business skill, with early movers gaining significant competitive advantages. This token economy explosion is attracting attention from an unexpected source. Investors who see these usage patterns as signals of where the real money is flowing. AI investment gold rush. Investment flows now rival previous tech booms, but are grounded in real revenue models rather than pure speculation. Where the late 1990s saw wild speculation on companies with no revenue, today's AI investments target companies already generating substantial returns. The numbers are staggering, but they're backed by real business models and measurable outcomes. Investment patterns reveal which AI sectors attract the most serious money. Infrastructure plays dominate the landscape, with billions flowing into hardware development, data center expansion, and compute capacity to address the documented 10-gigawatt shortfall in data center capacity. Application layer innovations follow closely, particularly companies building practical AI tools for specific industries. Agentic coding has emerged as a breakout use case, with companies like Replit and Lovable reaching $100 million in annual recurring revenue, demonstrating the massive revenue potential of AI agent applications. Valuation metrics defy traditional investment logic. Some AI startups reach billion-dollar valuations in record time, driven by rapid user growth and revenue acceleration rather than speculative hype. What separates these companies from dot-com-era failures? They solve real problems and generate measurable value from day one. The shift from venture capital to strategic corporate investment reveals how established companies are buying their way into the AI future. Microsoft, Google, and Amazon aren't just investing money. They're acquiring capabilities, talent, and market positions through strategic partnerships and acquisitions. Investment success rates show clear patterns. Companies focused on specific use cases with measurable ROI attract the most stable funding. Those chasing general AI capabilities without clear applications struggle to maintain investor interest. But behind all this investment activity lies something that challenges basic economic assumptions about supply, demand, and pricing. The great AI cost paradox. Here's a counterintuitive reality that breaks economic logic. As demand for AI skyrockets and infrastructure struggles to keep up, costs are actually plummeting. While token demand grew 4,300% between June 2024 and May 2025, inference costs dropped precipitously with no end in sight. This paradox creates opportunities that seemed impossible just months ago. AI inference costs have fallen so dramatically that what was once economically unviable is now routine. Applications that required careful budget planning now run continuously without financial concern. Anthropic had to throttle developers who were running Claude 24/7 because the costs became so affordable that constant usage made business sense. This enables entirely new ways of working with AI systems. Technological innovations drive these cost reductions. More efficient algorithms process the same tasks using fewer computational resources. Specialized hardware architectures optimize specifically for AI workloads rather than general computing. These improvements compound, creating cost reduction trajectories that defy traditional technology economics. Competitive dynamics accelerate the cost spiral downward. Major providers race to offer the most affordable AI services, triggering price wars that benefit everyone except profit margins. This competition democratizes AI access, allowing smaller companies to compete with tech giants using the same advanced capabilities. Cost reductions create entirely new market opportunities. Price-sensitive industries that couldn't justify AI investments now adopt these technologies rapidly. Small manufacturers use AI for quality control. Local restaurants implement AI customer service. Industries that seemed immune to AI transformation suddenly find these tools accessible and practical. This cost paradox is reshaping more than just business models. It's redrawing the global map of who can access and benefit from AI capabilities. AI's global geography. The compute shortfalls documented by J.P. Morgan create global winners and losers in ways most people don't expect. Regions with abundant power and cooling capacity gain massive competitive advantages in hosting AI infrastructure. Countries that can supply the 10 gigawatts of missing data center capacity will attract the companies and investments driving the AI economy. Different regions specialize in distinct aspects of the AI ecosystem based on their natural advantages. Some focus on manufacturing AI hardware at unprecedented scale. Others build research hubs attracting global talent. Certain countries create specialized AI applications for specific industries. These regional specializations create interdependent networks rather than isolated competition. AI sovereignty emerges as a national security concern. Countries develop domestic AI capabilities to maintain control over their technology and data. This focus reflects strategic imperatives to protect national interests and ensure technological independence. Regulatory environments shape AI development trajectories dramatically. Some regulations slow deployment, but increase trust and adoption rates. Other countries create regulatory sandboxes that accelerate experimentation. Nations with AI-friendly policies attract international companies, while restrictive approaches push development elsewhere. Geographic advantages create new centers of AI power that challenge traditional tech hierarchies. Cheap renewable energy attracts AI training operations to unexpected locations. Countries with strong technical education systems produce skilled AI workforces faster than established tech centers. Regions with existing infrastructure can deploy AI systems while others struggle with basic capacity constraints. Here's why this matters. The global AI landscape creates new competitive dynamics that extend far beyond technology into economic power and international relationships. But the real surprise lies in which specific industries are actually winning this transformation. Industry AI champions. Manufacturing companies deploy AI faster than software startups. Healthcare organizations automate workflows that tech companies are still discussing. Traditional sectors embrace AI because they face operational pressures that AI can solve immediately. A manufacturing plant sees direct cost savings from quality control automation. A hospital reduces patient wait times with AI scheduling. Tech companies often get distracted by building perfect solutions instead of implementing practical ones. Coding assistance leads enterprise adoption. with 77% of companies using AI agents for development work. Each sector develops specialized applications that require deep industry knowledge. Healthcare creates AI for patient diagnosis. Finance builds AI for risk assessment. These applications take years to develop and create competitive advantages that outsiders can't easily copy. Survey data reveals that 66% of leaders believe agents are increasing productivity, helping with cost savings and improving decision-making speed. Companies adopt a hybrid approach, with 46% equally focused on efficiency improvements and new revenue opportunities. This dual focus drives both productivity gains and innovation across various industries. Success patterns emerge from companies that integrate AI into their core business strategies, rather than treating it as a software consideration. Winners start with specific use cases and invest heavily in employee training. They understand that only 22% of organizations report architectures fully supporting AI workloads, so they prioritize data integration and infrastructure readiness. Industry-specific AI adoption patterns are creating new competitive dynamics that reshape entire economic sectors. But these rapid transformations are happening in a regulatory environment that's struggling to keep pace with the speed of change. Regulatory reality check. Companies face immediate barriers that function like internal regulations, creating compliance challenges that slow AI adoption regardless of government policies. Only 22% of organizations report that their current architectures fully support AI workloads. Data silos prevent AI systems from accessing the information they need. Legacy infrastructure can't handle modern AI processing requirements. These technical constraints create their own regulatory environment that companies must navigate. Corporate adoption patterns reveal how internal barriers shape AI deployment more than external rules. Companies spend months restructuring data systems before implementing AI tools. They rebuild entire workflows to accommodate AI capabilities. These internal compliance requirements often take longer to resolve than waiting for government regulations. Different organizational approaches create vastly different outcomes for AI implementation. Some companies establish internal AI governance committees that slow deployment while ensuring safety. Others adopt rapid experimentation frameworks that accelerate development but increase risk. Each strategy produces different innovation patterns and competitive advantages within the same regulatory environment. The compliance challenges create paradoxical effects on AI development. Companies with strong internal governance often deploy AI more successfully because they've addressed fundamental infrastructure issues. Organizations that rush implementation without proper preparation face technical failures that set them back months. This creates a competitive advantage for companies that invest in proper AI readiness. These internal regulatory hurdles are reshaping how companies approach AI adoption, but they're also creating unprecedented demands for new types of expertise that most organizations simply don't have. The great skills reshuffling. The workforce transformation goes beyond just finding new talent. AI is simultaneously creating massive skill gaps while making some highly valuable skills obsolete overnight. Companies desperately need AI talent, while traditional roles disappear faster than workers can adapt. AI talent commands significant premiums as companies scramble to fill new roles like prompt engineer and AI ethicist. Machine learning specialists see bidding wars between companies desperate for talent. These positions require unique combinations of technical understanding and domain expertise that traditional education hasn't prepared workers for. New job categories that didn't exist 2 years ago are emerging rapidly. AI trainers teach systems-specific industry knowledge. These roles bridge technical capabilities with industry-specific requirements that only experienced professionals understand. Educational institutions are scrambling to adapt curricula, often lagging years behind industry needs. Universities add AI courses to computer science programs. Business schools integrate AI strategy modules. But academic timelines can't match the pace of technological change, creating persistent skill gaps. Which traditional skills are becoming more valuable in an AI world versus those losing relevance? Executive surveys reveal that decision-making and teamwork are viewed as critical for managing AI agents effectively. Creative problem-solving gains importance since AI handles routine tasks. Data analysis skills become more critical as AI generates insights requiring human interpretation. Meanwhile, repetitive data entry, basic coding, and simple research roles face automation pressure. Retraining success rates vary significantly based on approach and timeline. Workers typically need 6 to 12 months for basic AI tool proficiency. Advanced AI skills require focused learning over longer periods. The AI skills revolution is creating dramatic workforce transformation, with early adapters gaining advantages that translate directly into measurable business results. Revenue rocket ships. These workforce advantages translate into something even more remarkable. AI companies are achieving revenue growth rates that break traditional business scaling models. We're talking about companies going from zero to billions in revenue, faster than any technology wave in history. Anthropic's revenue jumped from $1 billion to $5 billion within months, illustrating the unique scaling dynamics that separate AI businesses from everything that came before. AI revenue acceleration follows completely different patterns than previous technology waves. Traditional software companies took years to reach massive scale. AI companies do it in months because their products improve automatically and scale without linear cost increases. One AI model can serve millions of users simultaneously without proportional infrastructure growth. The revenue models proving most successful span multiple approaches. Subscription services dominate consumer AI, with users paying monthly for continuous access. Usage-based pricing works for enterprise customers who pay per token or API call. Platform plays generate revenue by taking cuts from third-party developers building on their systems. Each model creates different growth trajectories and customer relationships. Traditional companies see revenue boosts from AI integration in unexpected business lines. Insurance companies use AI for claims processing and generate new revenue streams from faster service. Retailers implement AI recommendation engines and see sales increases of 20 to 30%. Manufacturing companies use AI for predictive maintenance and create new service offerings. Winner-take-all dynamics emerge in AI markets because network effects and data advantages compound rapidly. Early leaders capture disproportionate market share through better models trained on more data. Revenue per employee metrics for AI companies show productivity levels that seemed impossible in traditional businesses. But this explosive revenue growth creates infrastructure demands that threaten to overwhelm the systems supporting it all. Data center crystal ball. The scale of infrastructure expansion required reveals why these shortages will persist for years. JP Morgan's projection of a 10 gigawatt data center capacity shortfall becomes more alarming when you consider construction timelines. New facilities require 18 to 36 months from planning to operation, with lead times for specialized equipment stretching even longer. AI workloads place completely different technical requirements on data center infrastructure. Traditional servers need steady power and basic cooling. AI systems demand power density levels 3 times higher than normal operations. Cooling systems must handle heat loads that would shut down regular data centers. These requirements force complete redesigns of infrastructure that took decades to perfect. Location strategies for data centers are changing dramatically. AI-specific needs drive these decisions now. Low latency requirements push data centers closer to population centers. Energy availability becomes the primary factor, since AI systems consume massive amounts of electricity. Some companies relocate operations entirely based on power grid capacity. Massive data center expansion creates serious sustainability challenges. Environmental impact assessments show concerning trends. Energy grid strain forces utility companies to build new power generation capacity. Some regions struggle to provide enough electricity for existing operations while planning major expansions. Data center capacity planning has become a strategic national and corporate priority, affecting energy policy and economic development decisions worldwide. But here's what makes this infrastructure race even more critical. The systems these data centers support are improving at rates that nobody predicted. AI model performance race. Model performance improvements are driving this infrastructure demand through capability advances that exceed all predictions. OpenAI's agent benchmarks reveal that ChatGPT agents now outperform or match human performance in nearly half of complex professional tasks. Performance curves that experts thought would level off are actually accelerating. Models that struggled with basic reasoning 6 months ago now handle complex problem-solving that required human expertise just weeks earlier. The Meter study's consistent tracking methodology shows these improvements following exponential patterns. Tasks that took agents days to complete now finish in hours, with performance doubling cycles accelerating from 7 months to roughly 70 days. These aren't incremental improvements. We're seeing capability jumps that redefine what's possible across multiple domains simultaneously. The areas where performance gains are most dramatic span reasoning, creativity, and specialized knowledge domains. Language models now perform multi-step logical reasoning, with accuracy rates approaching human levels. Creative AI generates artwork, music, and writing that wins competitions against human creators. Specialized models master complex fields like medical diagnosis, legal analysis, and scientific research. Performance improvements create entirely new application possibilities. Markets that didn't exist before emerge as AI capabilities cross critical thresholds. Companies build products around AI features that seemed impossible months ago. Industries discover use cases they never considered as model performance reaches new heights. The relationship between model performance and adoption rates shows clear patterns. Capability thresholds trigger mass adoption when AI systems become reliable enough for practical use. These rapid improvements are reshaping competitive dynamics as companies race to leverage the most advanced capabilities available. The consolidation game. Market power is concentrating among a surprisingly small number of players, despite thousands of AI startups launching every month. The AI ecosystem looks diverse on the surface, but underneath, a handful of companies control the infrastructure, talent, and resources that determine winners and losers. Microsoft's strategic infrastructure deal with OpenAI secured compute infrastructure, talent pipelines, and market positioning that smaller competitors can't match. Google's acquisitions focus on specialized AI research teams rather than products, building long-term competitive advantages through talent concentration. These partnerships provide access to distribution channels, customer bases, and resources that would take years to build independently. Successful AI companies build competitive moats that compound over time. Data advantages create better models, which attract more users, which generate more data. Compute scale allows faster experimentation and deployment of larger models. Winning AI platforms build multi-sided developer ecosystems that newcomers struggle to replicate, creating network effects where established players attract both developers and users simultaneously. AI platform plays emerge as companies build ecosystems rather than standalone products. These platforms create developer communities, third-party integrations, and network effects that make switching costs prohibitive for users. Platform strategies generate revenue from multiple sources while creating barriers for competitors. Market share concentration accelerates in sectors with high infrastructure requirements and network effects. The AI market structure is solidifying faster than expected, creating clear winners and losers across every dimension we've examined. This consolidation isn't just reshaping individual companies. It's creating the foundation for an entirely new economic structure. Conclusion. These 15 data points reveal how 4 critical dimensions are reshaping our world simultaneously. Consumer adoption exploded with ChatGPT reaching 100 million users in 5 weeks. Enterprise paid subscriptions jumped to 42% as companies moved beyond pilot programs. Agent performance now doubles every 70 days, with AI matching human capability in half of complex tasks. Token consumption surged 4,300% year-over-year as infrastructure struggles to keep pace. The convergence creates compound acceleration across every sector. Consumer adoption drives enterprise demand. Enterprise deployment fuels infrastructure investment. Infrastructure scaling enables better AI models. Better models accelerate adoption everywhere. This multiplier effect will define the next decade. What does this mean for you? Understanding these patterns positions you for a future arriving faster than expected. Which AI trend surprised you most? Share your thoughts below.